In this next video, we are going to be simplifying products or quotients with different indices. So they have a different index. Some could be a square root, some could be a cube root. How do we multiply and divide those? Well, the key is our rational exponents. So you might not have directions that say to use rational exponents. It might just say combine the radicals or simplify the radicals or something like that. And you have to know that if they're different indices, you need to change it into a rational exponent. If they have the same index, like a square root times a square root, that's fine. Just multiply everything underneath together. But if it's a different index, you must change it to a rational exponent. So remember, with rational exponents, the numerator is our exponent, our power. The denominator is the root. Okay? So we're going to rewrite this square root of x cubed. The exponent is 3. The root is 2. Exponents go in the numerator, roots go in the denominator. That's times the fifth root of x. So this is like x to the first power. So the numerator is 1. The root, the denominator, is 5. Now we have a base times a base. What do we do with these exponents? Do we add or multiply them? We add them, right? So essentially I am adding 3/2 plus 1/5. How do we add fractions? They have to have a common denominator. The LCD here is 10. Multiply the first fraction by 5, second fraction by 2. And I've got 15/10 plus 2/10, and I get 17/10. So that's x to the 17/10. And then from there, you need to change it back to a radical. So in general, if you start with radicals, you should end with radicals, unless otherwise instructed. And this says to combine the radicals here, right? So we need to end with a radical answer. So if I change that back into radical notation, again, that exponent is the numerator. The denominator is our root. And then you need to ask yourself, is that simplified completely? And the answer is no, because there's more than 10 x's underneath that 10th root. So I can split up that x to the 17th. I'm going to just write it over here as x to the 10th times x to the 7th, right? I need perfect or powers of 10 to be able to take the 10th root. So that x to the 10th, I can take the 10th root of. I would get just x, right? The 10th root of x to the 10th is x. And then I'll still have the 10th root of x to the 7th because there's not enough there to take out. And that's as far as we can go. What if I have a quotient? What do I do with that? Because in the numerator, I have a square root, but in the denominator, I have a fifth root. Again, they're not like indices. I cannot bring them together because this is a square and this is a fifth root. So again, I rewrite it with rational exponents. That quantity 2x, I'm taking the square root. So it's to the first power. The root was 2. In the denominator, I still have that quantity 2x. Only now the power is 2, the exponent is 2, and the root is 5, fifth root. What do we do with the exponents when we are dividing? We subtract them, right? So I'm taking 1/2 and subtracting 2/5. Same idea. I need a common denominator. Multiply by 5, multiply by 2, and I get 5/10 minus 4/10. and 5 minus 4 is just 1. So 1/10. So that whole quantity goes to 2x to the 1/10 power. That means the exponent is 1 and the root is 10. And there's nothing else to simplify there. Try the 2 examples on the right. Okay, I gave you guys one that was a little bit harder. Let's see how you did. So I'm taking the 4th root of a times b squared and multiplying it by the 7th root of a squared b to the 6th. Now everything under these radicals, these are factors, they're being multiplied, so we can use that product property that says I could split everything up into its own radical, right? That's the product property of radicals. You don't actually have to write this step for me on a test or anything, but I'm just showing you why it's possible. Okay, so product property, split everything under its own radical, and then I'm going to write all of these with rational exponents. So the 4th root of a, the exponent to a is 1, the root is 4. And for b, we had an exponent of 2, and the root was 4, which we can simplify down to 1/2 in a moment. The second a, we had an exponent of 2, and the root was 7. And then lastly, that b, the exponent was 6, and the root was 7. Now we're going to rearrange this because these are factors again, things being multiplied, and multiplication is commutative. So I'm going to put the a's first. A to the 1/4, that's a 4, times a to the 2/7 times b to the 2/4 is the same thing as 1/2. So I'm just going to write b to the 1/2 times b to the 6/7. All of these are a base times a base. We need to add those exponents. I'm going to start with 1/4 plus 2/7. So only like bases can be combined. And I have 1/4 plus 2/7. They need a common denominator. Multiply by some 7s, by some 4s. I have 7/28 plus 8/28. 7 plus 8 is 15/28, right? So add the numerators, the denominator stays the same. So a to the 4th times a to the 2/7 is a to the 15/28, right? Alright, same thing with the b's. I have 1/2 plus 6/7. Base times a base, we add the exponents. They need a common denominator. Multiply by 2, or 7, multiply by 2. I have 7/14 plus 12/14. 7 plus 12 is 19/14. So that's b to the 19/14. And again, we want to rewrite this with radical notation. So if I want these to go under the same radical, they need to have the same denominator. So I'm going to go ahead and make that 19/14 into a denominator of 28. So I'm just going to go ahead and multiply by 2, both the numerator and the denominator, and get b to the 38/28. So now they have the same radical, and I can rewrite it as the 28th root of a to the 15th b to the 38th. Now I'm not quite done. Why do you think I'm not quite done? I have too many b's. Right, so that a to the 15th is fine. I need 28 to be able to take something out. I only have 15 a's. But I have 38 b's. So b to the 38th is the same thing as b to the 28th times b to the 10th, right? And those 28 I can take out. So one last step here, I have the 28th root of b to the 28th, which will just be b, and the 28th root of a to the 15th times b to the 10th left underneath that radical. And that's as far as you can go on that one. Alright, one more. Now again, I have a quotient, but I need to start by rewriting these with rational exponents. So I have y, the exponent is 2, so that's the numerator. The root is 3, that's the denominator. Over y, the exponent is 3, the root is 7, so 3/7 power. The way we simplify with division is we subtract the exponents. 2/3 minus 3/7. We need a common denominator, so I multiply by 7 on the left, multiply by 3 on the right. Now I have 14 21st minus 9 21st. 14 minus 9 is 5 21st. So when I subtract those exponents, we get y to the 5 21st power. And then I'm going to rewrite that in radical notation as the 21st root, because that was the denominator, of y to the 5th. I need 21 y's to be able to take it out of that root. I only have 5. So this is all we can do. And there you have it. So if you're trying to divide or multiply radicals with different indices, you need to use rational exponents.